Hello students, today we are going to see some of the problems on filters. Okay, so the theory is discussed with you already and the notes is provided. Just to see how this works actually, how the operations on filter can be performed, we are going to see that in this video. Now, first problem here is stated, calculate the new value of the pixel 1, 1 using box filter to smooth the following image, and they have mentioned the size of that box filter also, that is 3 cross 3. Now what is this box filter? And here they have told that you have to use the box filter itself, so we have to see what is this box filter. A box filter is a low pass filter that smooths the image by making each output pixel the average of the surrounding ones, removing details, noise, and edges from the images. And how we can implement that? The box filter is implemented as a convolution operation on the input image. Input image is given to you already, and the kernel for that filter is also given. That is, the box filter is implemented as a convolution operation on the input image using the following kernel. Here you can see box of m comma n is equal to 1 by mn. 1111 is shown as the elements of this. Okay. Now let's see how we can solve the problem by applying this box filter. Here they have specified you to use the box filter itself. Now this is our input image. Now, there they have told you the location to where we have to apply the filter. Calculate the new value of the pixel in this particular 1 cross 1 comma 1 pixel. See in this image, first we have to see where is our 1 comma 1 pixel. Here what is the number of rows? 1, 2, 3, 4, 5. Okay. Number of columns 1, 2, 3, 4, 5. Now in this, where is my element 1 comma 1, or where is my pixel 1 comma 1? Starting from this as my 0, 0th row, 1th row, second row, third row, fourth row, my 0th column, first column, second column, third column, and fourth column. Where is my 1 comma 1? If you see, 1th row, 1 column. So this is the pixel we have to consider. So what is the value of that pixel? It is 58. Pixel 1 comma 1 is having the value of 58. Now there they have mentioned the box filter of size 3 cross 3. So how we can consider that? See, the filter to be used for this operation is 3 cross 3. The filter elements is always 1, that you have seen. See here, the elements are shown here as 1 1 1. Okay, so the elements inside that filter should be 1. So here you can see, the elements are 1 1 1 1 1 1 1 1 1. Okay, now since they have told the location as this 1 comma 1, we will take this as our central pixel. So if this is my center pixel, so I have to consider 3 cross 3 filter size. So this is somewhat region I have to consider. This is the region. So that region is written over here separately. Your 58 is the center pixel surrounded by these many elements. Now in the box filter operation, the box filter is implemented as a convolution operation on the input image using the following kernel. So this is our image what we are considering. Sorry, this is the image what we are considering, and this is our box filter. Okay, now this is my 1 by mn. Number of rows here is sorry, mn 1 by mn in the sense 1 by 3 comma 3. Here the image what I am considering is somewhat 3 comma 3 here, and this filter size is also 3 comma 3. So this is 1 by 3 comma 3, 1 by 3 comma 3, which is nothing but 1 by 9. Now you can see this is also 3 comma 3 and this is also 3 comma 3. So this is 1 by 9, and multiplying this with 111, this is my box filter what I am considering. So I have to perform the convolution operation. How I can perform that? How I have to perform that? The first thing is that 1 by 9 I have to consider as it is. Now I have to place this filter over this image. Okay. Now how I can do that? There is a procedure for that. Okay. Now see this filter. If I place this filter on my image, here it is. So this one will be there, no? This will be placed on this 50. This one 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 center will be placed on this 58. This one will be placed on this 50. This one will be placed on this 50. This one will be placed on this 50, and this one will be placed on this 50. So now I have to perform the convolution operation. Okay. Now how to perform the convolution operation? See here, this 50 when it is placed on this 1, this 50 will be placed on this 1. So that is written here as 50 into 1. Later convolution in the sense, first we have to multiply, then we have to add. First we have multiplied this 50 with 1, then adding this with the next element multiplication, that is 50 with this one, last 50 with this one. So 50 into 1 plus 50 into 1 plus 50 into 1. Now moving to the second row, that is again this 50 is multiplied with this one. Okay, this 50 is with so this 50 with this one, that will start from this part 50 into 1. Now moving to the pixel 1 comma 1, that is your center pixel. 58 multiplied with this one, this 50 multiplied with this one. Now moving to the third row, 50 multiplied by 1, this 50 multiplied with this one, and this 50 multiplied with this one. So when you add these things, when you add these all multiplication terms together, that is convolution essence, first you will perform the multiplication and then the addition, right? And if you simplify this entire thing and if you multiply that with this 1 by 9, 1 by 9, you know how we got that, isn't it? The filter size what we are considering is given here as m cross n. So this is the filter size that we are considering here in the denominator. In the same way, here the filter what we are considering is m cross n, that is 1 1 1 1 1 1 1 1 1. This is 3 cross 3. So my mn will be 3 cross 3, which is equal to 9, isn't it? So I got this 1 by 9. Now 458, the entire solved thing over here, divided by 9. If I do that, I will get 50.88. Pixel value is somewhat, it's a whole number, so I have to approximate that to 51. Now moving to the next filter operation, that is average filter. What is the question here? Apply the average filter to the pixel 1, 1 using a 3 cross 3 neighborhood matrix. Okay, average filter is the operation what we have to do. Now here the pixel of interest, or the pixel what we have to consider here is, what is that? It is pixel 1, 1. So in this particular image, what is that 1, 1? Again we have to write 0, 1, 2, 3, 0, 1, 2, 3. So if I do that, 1, 1 will come at this particular location, that is 15. So this is my center pixel. By considering this, I have to solve. Here what they have told, apply the average filter to the pixel 1, 1 using 3 cross 3 neighborhood matrix. So if this is my center pixel, my 3 cross 3 matrix would look like this. Center pixel is 15, 3, 9, 11, 7, 15, 8, 10, 12, 9. New pixel can be calculated by, what is the operation we have to do? Average filter. Average in the sense, what is it? First, if you are generally, if you are asked to solve, or if you are asked to calculate the average, first you will do the sum, isn't it? Sum of all the elements. Or if you are given with some 10 numbers, 10 different numbers, if you are asked to get the average of that, what you will do? First you will add all the 10 numbers divided by number of elements, that is 10 in this particular example. 10 in the, suppose you are given with 10 numbers, in the sense you will add those 10 numbers divided by 10. Whereas in this case we are considering this 3 cross 3 neighborhood matrix, so this is the matrix. So in the numerator we have to consider the sum of all the elements, that is 3 plus 9 plus 11. This corresponds to the first row elements. Second row element is 7, 15, 8. Third row element is 10, 12, 9. Isn't it? First row, this is my second row, and this is my third row, divided by total number of elements. How many elements are there? It is 9. So if I do, the answer will be approximately 9.33. So I have to approximate that to 9. Now I have to get a new value, right? After doing so many calculations, I have to get a new value for my center pixel. So this 15, 1 comma 1 pixel was 15. So after doing this particular operation, I have to replace this 15 with the new value, that is 9, the obtained value. Rest every element was same. The center pixel value, I have to, 1 comma 1 pixel value, I have to replace with a new value or new calculated value, that is 9. Now moving to the next operation, weighted average. Okay, see, weighted average, what is this? The apply weighted average filter to the pixel 1 comma 1 using a 3 cross 3 neighborhood. Okay, now see, in this also, can you tell me what is the pixel 1 comma 1? This is my 1, 0, 1, 2, 3. If I do that, this is my pixel which I have to consider. See, consider the 3 cross 3 neighborhood matrix and put it on the original image, and you will put the center value of 3 cross 3 neighborhood matrix, that is 4, exactly on the 1 comma 1 pixel value of the image, and new pixel value can be given by. See, here we have to consider one 3 cross 3 neighborhood matrix. Later we have to put that, see, let us consider this as our matrix 3 cross 3. This is 3 cross 3 neighborhood matrix. We have to put this on our original image, this one. Okay, and we have to put this such a way that I have to place my center value of this 3 cross 3 neighborhood, that is 4, should be exactly on my 1 comma 1 pixel, that is 15 here in the image. Okay, now I have to perform the calculation. If I place this thing on my input image, and I have to make sure that this 4 is exactly on my 15 value, this 1 comma 1, then this 3 will on this 1 will be on my 3, this 2 will be on my 9, my 1 will be on my 15, this 2 will be on my 7, however 4 will be on my 15, this 2 will be on my 8, 1 will be on my 10, 2 will be on my 12, and 1 will be on my 9. So here also I have to perform this multiplication and later addition. So this 3 is multiplied with 1. This 9 is multiplied with 2. 11 is multiplied with 1. 7 is multiplied with 2. 15 is multiplied with 4 center pixel. 8 is multiplied with 2. 10 is multiplied with 1. 12 is multiplied with 2. 9 is multiplied with 1. Here also we are considering 3 cross 3. So average is what is asked here. So I have to consider average in the sense I have to, what was the thing which we have solved before? Here we have considered the number of elements in the this particular neighborhood matrix. Okay, this matrix is the one which we have considered, and we have to replace that center pixel by the average value, isn't it? We have considered this much region by considering this as my center pixel. Later I have what I have done, I have considered the sum divided by number of elements, but here the name is changed. Here there is one more term called as weighted. What is this weighted? Here one small change is there. The thing is that in the average filter you are dividing the sum with the number of elements, whereas in case of this weighted average, instead of dividing by the number of elements, we have to consider the sum of these 3 cross 3 neighborhood matrix, sum of the elements of this 3 cross 3. So what is that? If you do sum of the elements, 1 plus 2 plus 1 plus, this is for my first row, then 2 plus 4 plus 2, third row 1 plus 2 plus 1. If I do this, what I will get? This is 3 plus 4, then 6, 7, 8 plus 3, 4. What is this? 4 plus 8, 12. 12 plus 4 is 6. 12 plus 4 is, what is 12 plus 4? 12 plus 4 is 16. This sum we are considering in the denominator. So 16 you will get by adding the elements of this 3 cross 3 neighborhood matrix. If I solve this entire thing, I will get the answer as 10.3. Converting that, or considering the whole number, 10.3 can be approximated to 10. So in the new matrix, what we will get after applying this average filter? Original image you got, that is 4 cross, this is the original image. Okay, there you have considered only that 3 cross 3 region. To that you have applied this weighted average. Now your work is to replace that center pixel, that is 1 comma 1 pixel value, with a new calculated value. What is that new value we got? That is 10. So your 3, 9, 11, everything remain as it is. This is for your first row. Your center pixel is in this particular location, so it was 15 before, now it is changed to 10. This is your new value. Last row is same, 10, 12, 9. Now moving to the next operation, that is median filter. What is median? In generally, median in the sense, if you are given with some 5 or 6 numbers, okay, let me consider you are given with some 2, some numbers. Let us say it as some 2, 6, 8, 5, 3, 1, 0. Okay. So I have to, if I am supposed to calculate the median, what I have to do? I have to arrange this in particular order. So let me consider it as some ascending order. So let me arrange this 0, 1, 2, 3, 5, 6, 8. Every number is assigned, right? 0 is done. 1, 2, 3, 5, 6, then 8. 0, 1, 2, 3, 5, 6, 8. Now I have to consider the center element here, that is 3 in this particular case. I have left 3 elements after 3 and 3 elements before 3. So this is my median. Here what I have to do, let us see that. See, in this what happens is that we have to apply the median filter on 0, 0 pixel. So what is my 0, 0? This is my 0, 1, 2, 3, 4. This is my 0, 1, 2, 3, 4. It is my 0, 0, then it is 8. To this I have to apply. But the thing is that if I apply 3 cross 3 mask on this, I can see that if I place my 3 cross 3 mask center pixel, this is my 3 cross 3. If I consider the center pixel, okay, this on my 8, that is 0, 0 pixel, I can see that some of the elements will not be present. How? See here. See, this is my original input image. I have to place my mask over this location. For the above image, put a 3 cross 3 mask as shown below. We are putting 0 in this location. Why we are putting 0? Because we are putting 0 since we have 5 pixels outside the image in the mask. Here you can see this is a 0, 0. So these 5 pixel values are outside your image. We are putting 0 since we have 5 pixels outside the 5 pixels in the mask, that is outside the image. So we have to put 0. We are having 5 pixels in this mask which are outside the image. So now our work is to sort these elements. If I sort these elements in ascending order, what I will get? 0, 0, 0, 0, 0 will be placed first. Later 8, 8, 9, 12. 8, 8, 9, 12. Okay, now I have to consider the middle number. I am leaving 4 elements after this middle thing or middle number and 4 elements before this middle number. Now this is my value. So now I have to replace my 0, 0 with a 0, 0 pixel element, that is 8, with my 0. Now your 0, 0 pixel value will become 0 using median filter. Rewrite the pixel values of the image. Suppose if this is your image, okay, now after doing calculation, this is the this was 8 before. Now your work is to rewrite this such that everything is same except this first thing, because we are replacing that with 0. Now suppose this is the first case. There is one more case which is easy compared to this one. See, now we are going to apply the median filter for 3, 1 pixel of the same image. See, 3, 1 pixel in this image. 3, 1 in the sense, what is that? Third row, first column. This. Okay. Just a minute. See here. In this is the original image, right? Our work is to consider my 3, 1. See, 3, 1 is what is asked. In this image, my third, this is the 3 corresponds to the row number and one corresponds to the column number. So what is that? This 12 is the pixel what we have to consider. So if I do that, this is the region I have to consider. Here you can see 13, 12, 8, 14, 12 is the center pixel, 12, 15, 14, 13. This is what we have to consider. And later same thing, we have to sort the number in ascending order. So first thing what we have to get here is a 8. It is written. After that we have to write 3, 12. Then comes your 13 two times. Then is your 14 two times. Then last is your 15. Now if I sort this and if I remove four elements after your the middle element and four elements before, that is nothing but we are considering just the middle value of this sorted number, that is your 13. Okay, now what is that? 3 comma 1 was having the original value of 12. Now we are replacing that 12 with my 13. Now your 3 comma 1 pixel value will become 13. Now there is one note as given to solve for max and min filters. What is this max? Usually if you see this max, you are going to consider the maximum value. What is this min? You are going to consider the minimum value. Okay, suppose you are considering this particular structure. What is the maximum value? Here what we are having? It is 15. What is the minimum value what you are having? 8. That's it. Okay, now this is an example. In the same way, you can consider for your maximum and minimum filter if some other problem is given. Max corresponds to maximum filter. For example, I have taken this. Suppose you are given with any kind of matrices, the maximum value of the pixel or the minimum value of the pixel is the thing we are going to consider for your max and min filters. Okay, thank you.